Okay, so in the last video, we talked about how you can use retrievers to improve the accuracy of your chatbot and AI responses by using filtering and ranking methods to essentially prioritize the information that gets sent to your LLM for your final response. And in this video, what we're going to do is we're going to create our own Reranker using N8N. And what's really cool about this project is that not only does it showcase exactly what N8N can really do, it's also a great tool that you can use for just about any AI project that you're working on. And so, like we said in the last video, when it comes to retrievers, there's quite a few options that you have. But personally, I found issues with almost all of them. And so if we start with the Cohere Rerank Retriever, one of the things I like about it is that it does work pretty quickly. However, there are some limitations. And so one of the first limitations is that you can't really choose or upgrade the embedding model that it uses. And the second is that the pricing structure is a little inflexible. So Cohere, the Rerank retriever, basically works on a per thousand search pricing structure. So it's something like 2,000. It's something like $2 per every 1,000 searches. And so while that doesn't seem that bad, once you start really scaling, in development, it can be, like I said, a little inflexible. A better approach personally would be using something that's more token based. But that's why we're developing different alternatives. Okay. So the other ones, looking at the reciprocal rank fusion retriever, it works pretty well. The only issue I had with it was that it tends to remove documents from the final list that gets sent to your LLM. And, you don't actually have any real control over it either. So it'll just do it based on its own algorithms. And so, when it comes to actually having more fine control over your documents, I would actually like to have more control so I can actually, choose what I'm actually taking out. The multi-query retriever was a really interesting retriever model. Basically, what it does is it creates 3 different questions, and then it uses your vector store to actually retrieve those extra documents. And then it uses all of those documents to actually answer the question. And this was one of the most interesting. However, again, you're not really controlling the questions, even though they are fairly related. So this can definitely work for certain applications, but maybe not all applications. The embedding filters retriever, again, it really works based on just a simple similarity threshold. And so if you don't have a whole lot of documents to begin with that are retrieved, that might affect your answer. So again, it's a great idea. You just don't have a whole lot of control over which documents are actually returned. And then finally, the LLM filter retriever, it's using a large language model to basically, filter the documents. And so, as long as you're comfortable with the language model, I guess it's fine. But again, you lose a lot of control. So when it comes to actually rolling our own retriever, our own ranking retriever, we really want maximum flexibility. All right. We want to be able to have maximum control over our documents that get sent to the LLM for its final response. And so there's a couple different things that we were looking for when we were thinking about and designing our retriever. And the first is that we want to be able to upgrade to the latest embedding model, when we want to get better performance. And so, ever since OpenAI's Ada 2 embedding model came out, there's been a number of different embedding models that have actually outperformed Ada 2, and even the text embed 3 model, the next tier up. And so, we want to be able to have the opportunity to basically use different embedding models, when it makes sense. The second thing that we want to do, like I said, is we want to have more control over how we rank and how we filter documents, right? We want to be able to, essentially see what we're filtering and see what we're ranking so we can actually adjust our results. The third thing that we want to do is we actually want to have the ability to combine and rank documents from different sources. This is really important when it comes to, having a more diverse set of documents that we can use for our final LLM response. All right. And this actually will also improve the quality of our LLMs potentially as well. And finally, the last thing we wanted to do when creating our own Reranker is we wanted to be able to actually choose where we wanted to host it, whether we wanted to, self-host it on a VPS for, maximum flexibility, or using different providers, for example, using providers that have more powerful hardware. So we wanted to have all of these features when it came to creating our own re-ranker. So let's go ahead and take a look at exactly how the re-rank process works, all right? Because it's important for being able to create our own. So the first thing that we're going to do is we're going to take our query and we're going to take our documents, whether those documents are coming from a vector store or some other source. We want to take those documents and the query and create embeddings for each one. So in this case, we have created a vector embedding, which is basically just a list of numbers for our query, right? And this sort of represents the semantic, characteristics or qualities of our query. And then we're going to create document vectors for each of our documents. So even though you see one here, it actually would be 4. And then the next step in the re-rank process is we're going to calculate similarity scores for each document. So we're basically going to compare our query vector with each of our document vectors and then use that to produce a similarity score for each document. Once we've done that, we can actually simply do a sort and rank our documents based on similarity. And then those documents in that order will be sent to our LLM, all right? And so for this particular project, we wanted to actually have a process where we're able to rank multiple documents from different sources. In this case, our vector store, and also we wanted to use Brave search results. So there's a lot of cases where you may have uploaded documents, and over time, the information becomes outdated, or the situation changes, or you want to actually be able to do a live web search in addition to your documents, which actually can give you even better responses and better results, higher quality results. All right, so this is basically going to be the workflow, all right? And if we go ahead and we take a look at the documents that we're using the NVIDIA 2024 annual report. This is actually a great document for doing RAG on. It's very, very detailed. And so it's a great sort of showcase of, all of the things that NVIDIA has done, including, their financial results and, their sort of market research and their technology. And we've also added some other documents as well. This report, the state of AI in retail and CPG, so we can kind of get more trend information. And so using all of these, we are going to create our standard RAG, right? This is our standard RAG model. And as you can see, we've been sort of asking some questions here. And so normally what happens when you are using your RAG model is you ask a question, and then that question, that query gets applied to your vector store, and then you actually get documents that are sent to your final LLM, right? In this case, it's our conversational retrieval QA chain. But if we actually kind of want to see what that looks like, what we can do is we can modify this chat flow and introduce a custom retriever, which is basically going to get all of the information from our vector store, and then we can pass it to a custom JavaScript function node that basically just returns those documents. So we've already done that, and we've asked a question. And with this particular chat flow, you can see that it doesn't give us an answer. It actually gives us all of the documents that were returned by the custom retriever, okay? And so essentially, we want to be able to take these documents, and we want to, and these documents are not ranked. It's just, which came first. Whatever document whatever chunk in our vector store matched our query, that was listed first, right? So we basically want to take all of these documents, and then we want to re-rank them and then send them to our final LLM. And so for this, we are using N8N. And so this took quite a while to actually develop, because this particular workflow, it uses a lot of custom code to actually create the re-ranking algorithm, the re-ranking workflow. But the actual workflow itself is fairly straightforward. Okay, so initially, like we said, we asked the question, the query, and then we actually got the documents from our vector store. And so the way this workflow works is those documents are passed to our webhook, right? And then what we're going to do is we're essentially going to, format some of our documents here, format the data, and then we're actually going to create individual documents. So if you go ahead here and check out the Create Documents node, what you can see is that it's essentially taking our query and it's taking our documents, which is basically one big text string, and it's actually creating multiple snippets, right? Multiple documents that we can actually use later on in the embedding and re-ranking process, right? So in this case, it's creating about 20. There's about 20 chunks or 20 documents that it generated initially from our RAG pipeline. And then the question here is, what are 7 strategic moves NVIDIA can make in the data center and in the Gen AI space, all right? And so then what it does is it formats the documents so that we can actually use it later on. And then we have a function here where, we can filter documents at this stage if we want. And then once those documents are filtered or not, they can actually go to an embedding function. And for this embedding function, we're actually using the Nomic text embed. It's a very high performance embedding model that actually outperforms the OpenAI text embedding small model, as well as the Ada 2 model, right? According to the the MTEB benchmarks. And not only that is that this is a very high performance model. Actually, it's a very high performance open source model, and so it's a great choice for using it for this project. And so what happens is that once we filter those results, if we click on this embedding node here, you can see that these are the snippets, and you can see that this is the embedding vectors that we're using. Now, there's quite a few. So if we go ahead here and we actually change this temporarily, so what we're going to do is we're going to say to results so we can filter it. And then what we're going to do is we're going to go ahead and we're going to pin this information. We do this whenever we're testing our workflows. We're going to pin that data to the node, and then we're going to essentially go ahead here and we're going to basically re-embed those 2 documents, all right? The 2 documents that we just filtered. And the Fireworks API, because it uses Nomic as well, and it's extremely fast, and we're only embedding 2 right now, you can see the individual vectors here, okay? So you can see that it actually created the vectors, and this is a 768 dimension vector, okay? And so it did the same thing for the second document, all right? And so what it's going to do is it's going to pass that through an adapter here so we can actually format the results and get the exact JSON structure that we want. And then up here, we're going to do the same thing with our question, right? So we're basically embedding the question separately from our documents. So as you can see, the question is going to be passed on to the right-hand side here through our embedding node here. And so again, it's only a simple question, so it won't take that long. So you can see the queries here. So if we pin that, then you can see that these 2 get merged. So these vectors get merged, the query vector and also your documents vector. And then finally, we have a ranking cosine calculation. And this basically evaluates the similarity. This basically calculates the similarity score for each of the documents. So we go ahead and click on that. We can see that in this test, it's already created a similarity score. And then that will essentially be re-ranked and then sent to our final LLM on the other side. And so in this case, I believe they're already re-ranked. But you can see that it basically re-ranks the documents. Okay. So this is how our re-ranking model works. And if we go ahead and actually test this, again, we're using the Fireworks Nomic API, so the results are pretty fast. But let's go ahead and test this out. And so again, remember this is connected to our NVIDIA PDFs. So let's go ahead and ask a question here. And we're going to expand this. Let's bring this out. I'm going to say, what were NVIDIA's annual revenues and profits in 2024 by industry sector? Okay. And if we ask the question, and so we can see that the top revenues and profits were the data center. And so they had $47 billion in revenue. And then it says not explicitly stated, but it says the compute and networking segment, which includes data center, had an operating income of 32 billion. Okay. And then it gives you the rest of the figures. Okay. And so now if we ask another question, let's go ahead and ask, what is NVIDIA doing successfully when it comes to the data center better than their competitors? And so it gives us a pretty in-depth answer. And then the last question is, what were the highlights of 2024 for NVIDIA, and what things did they do well as far as developing data center and Gen AI tech? And so it takes a few seconds. Okay, so that took a little longer than expected, but now let's go ahead and actually check out the actual execution workflow on the back end, and that is for Brave Search. Okay, so we take a look here. We can see that the first question we asked took about 1 second, as well as the second one, and then the third one, it actually took 1.3 seconds. So there might have been some delay on the LLM side. But if we go ahead and check out the first question that we asked, we can see that this was the code here. This is the initial code, and you can see that we asked the question, what were NVIDIA's annual revenues and profits in 2024 by industry sector? All right, and so now we can see that it generated the embeddings, although usually when the output is very large, it doesn't show it to you, so it doesn't slow down your system. And so what we're going to do is we're actually going to go to the cosine module calculation, and you can see that we have the actual individual similarity scores. And in this case, we were actually filtering for 30. So we had up to 30, documents that we were passing to our embedding module. And in reality, we actually had 19 that were returned. And this is actually controlled by the in this case by the our Chroma database. Okay, so that's basically how it works here. And so if we click on this, we can see that it definitely ranks it. Okay. And so the Fireworks API, it is blazing fast. And so if you want something that works very, it's very responsive, it's a great tool that you can use. All right. So, okay. Well, so we've basically built a Reranker for our RAG pipeline. Okay. And now what we want to do is we want to basically do the same thing for our Brave search results. Okay. So again, we want to be able to use our Brave search results to basically add to the information, have it more diverse, and actually maybe even have it more up to date, depending on our PDFs. And so essentially our Brave search Reranker is actually going to be pretty much the same thing. The only difference is going to be the data source. So instead of passing the documents directly into the webhook, what we're going to do is we're basically going to pass the question into our webhook, and then we're going to use the Brave API search to generate all of the documents right within the workflow. And then we do the exact same thing. We generate the embeddings for each of the snippets that we create, and we also generate the embeddings for the question. All right. And so if we go here and we click on the format JSON, and again, N8N is so powerful because it really allows you to just format and extract the data exactly the way that you want. And one of the things that are really, it's really powerful is its ability to create these custom JSON structures. Without it, we would not be able to actually create this model at all. Right. And so what you can do is you can essentially, take the information on the right, or I'm sorry, on the left, and then assign it to various structures. So in this case, for our snippets, we're actually creating an array of snippets, which may be different than what you see here. So the snippets here are actually they're sort of scattered throughout the document. And so what we were able to do was we were able to extract all of the snippets and then place them in a very convenient JSON structure. And N8N makes this really, really straightforward, actually. Okay, and so basically once we've done that, we generate the cosine similarity scores. And it basically allows us to rank those documents for our final processing, right? And you can see it here in the test data. Okay, so now that we have our reranker for both our RAG pipeline and for our Brave Search API, what we want to do is we actually want to put those together and create sort of like a super ranker, right? In this case, we call it the Pegasus ranker. And this is what that looks like, okay? So on the top, we have the reranker for our Brave API search. And then on the bottom, we have our reranker for our RAG pipeline. In this case, our NVIDIA PDFs and the Chroma vector store. All right. And so essentially what happens is that the documents in our question gets passed through into the webhook, and then the documents go here, right? And they get re-ranked. And then the Brave Search API also goes here and gets re-ranked. And then finally, we actually sort we display the top 15 results for each one, and then we pass those into another module, another node. We combine the documents so it's all one, and then we sort those, all right? And so this is a very, very powerful way to basically combine and fuse all of the documents coming in that you're using to create your final response. And what I also like about this is that you can actually switch out your embedding models, right? So on the right-hand side here, we have a few embedding models that we've been working on and testing. So we have a OpenAI embedding model, so basically using the text embed small models. And we're also using Ollama. So Ollama has a gnomic text embed model that it has integrated, and that you can use that as well, okay? And so if we go ahead and check out one of the tests here, you can see that the combined JSON documents for previous tests are basically combining our Brave search results as well as, if we scroll down, our vector retrieval, all right? So I wanted to actually see which ones were being mixed and which ones had a higher relevancy, a higher, similarity scores, right? And so you can see it's fairly mixed, right? And so here, I believe we only have a few, we only have maybe seven results, but we can actually change that. You can change the ratio here. You can change anything that you want. All right, so now let's actually see the front end of this and see what it looks like. And it's actually pretty straightforward, right? So for using this inside of Flowise, what we can do is we can have a custom JS function that basically calls our previous workflow here, our previous chat flow, where we returned the documents, okay? So, we basically, query our Chroma vector database, and then we return the documents, and then those are the documents that are being sent to our N8N workflow, all right? And so we take that, and we're sending those documents. Let's go back here. That's the wrong one. So we're taking that, and we're sending those documents to another custom JS function node that basically calls our N8N workflow, right? And so the documents along with the question are being passed, and then the output is essentially the combined re-ranked list of documents from both our Brave search results and also our NVIDIA PDF documents. And then those get sent to a chat prompt template, and then we create the final response there. All right, so let's go ahead and actually test this out. And so if we bring up our questions here, we are going to, the first one we're going to ask is this one. So we go ahead and see what the result is going to be. And it shouldn't really take a long time. And again, this is using the re-ranked results from Brave and also our PDF. And as you can see, it is very fast. It is very, very fast. All right. And so that's the first one, and it looks pretty good. So because it's using the PDFs as well as the Brave search results, we can get a much more comprehensive answer. And this is really good for this particular case because, there may be additional information, which, of course there is, for NVIDIA that are not inside of the PDFs. So, it's a great way to actually augment your PDFs. So the second question is, what is the 2025 outlook for NVIDIA stock? And what are 10 factors that can affect the revenue? So, the report was on 2024, but, in the time since they've published it, of course, there's information for 2025. So we go ahead and check that out. We can see that it gives us a forecast, an outlook, gives us this 10 factors. Okay, and so the last one is, what is the 2025 outlook for the retail furniture market? So we're trying to actually branch out and see how there are some trends that we can use, maybe some insights for creating our strategy for 2025. All right, for the furniture retail market. And so as you can see, some of this information is actually coming from the web because it wouldn't necessarily be in the PDFs that we used. And it's giving us a very, very, from the look of it, of course you'd have to read it, but from the look of it, it's giving us a very, very detailed information. And we also asked about, using generative AI, and that also can reference, some of the documents that we're using. All right. So if we go ahead now and we actually check out the back end of this, and we close this here, move this down, and then we look at the executions, and we can see that these are the last three, and the execution time was, 4 seconds, basically 4 seconds. So again, it's blazing fast. And this was the first question, and we're just going to go straight to the ranked documents. Okay, so if we go ahead and check out the final ranked documents here, the sorted list, we're going to see all of the documents. The top one is from our Brave search. And so the question was, let's see if it was the question at, oh, the question is actually in here. We'll have to look at it later. But the first one was from our Brave search, and then quite a few were from Brave, of course, because in this case, it was a bit more weighted toward, at the API, the Brave API search. And if we go ahead and we keep scrolling down, we see that the Brave search results pretty much dominated our rankings. And then if we scroll all the way at the bottom, we see that our vector retrieval came pretty much last. So it basically ranked the Brave search results, and then it gave us the vector search retrieval results. And, this is all based on similarity scores. And so in this case, our Brave results were actually more relevant than our vector results. So if we go ahead and look at the first question that we asked, it was, what were 5 strategic moves NVIDIA could take in 2025 to increase revenue? So this is something that, I would expect to basically come from the API search results. Okay, so if we look at the final sorted list here, this was the one we were talking about, the retail furniture industry. We can see that the Brave search results also dominated, which makes sense because you wouldn't necessarily find that inside of the other, the PDF documents necessarily. And so we scroll all the way down and we see vector retrieval, right? So the vector retrieval, the similarity scores were lower, all right? And so the AI is using all of these to basically create our answers. And so, of course, again, what you can do is, once you sort this, you can also, filter it again if you want. So you can basically really control the information that's passed to your LLM. All right. So this is basically how it works. And like I said, this is a really, really powerful way to re-rank your results and really give you maximum flexibility. All right. And so like we said earlier, you can actually use different models to actually do your embedding. And one of the really exciting parts about this is that you can actually use Ollama to actually do the embedding for you on your own server, using the Nomic text embedding models. So what we're going to do to test this is we're actually going to use just the Brave search Reranker, and we're going to use Ollama to do all of the embedding. All right. And so for our Flowwise chat flow, we're just using a custom JS function node that basically connects to our N8N webhook. And then we're going to pass the question in. We're going to get the documents, and then we're going to use that for our final response. So we go ahead and pull up our questions, and we scroll down. And so because we're not actually using our RAG pipeline, I kind of want to focus on questions just for 2025, right? Things that you obviously wouldn't find in any sort of documents that we have so far. And so what we're going to do is we're going to expand this, and then we're going to, again, this is using Olama, so the questions, the time might be a little bit different. And also, if we go ahead and look at our setup here, so for this flow, what we're doing is we're actually returning 50 results. And so basically to do that, we're just going to go here, and you can see just by changing the snippets slice number here, you can actually return however many results that you want. And we're just doing this to sort of test the actual amount of time it takes. And so let's go here and then ask the question, what are the 2025 trends for video game development using Unreal Engine? All right, so it's going to do that web search. And normally when we have about 20 results, it takes about 15 to 17 seconds to actually process it and then return the results or return the documents back to us. In this case, we're actually embedding 50 results, up to 50 results. So it might take a little bit longer, but we'll see exactly how long it takes on the front and the back end. So as you can see, the response time is not bad. Okay, it's not bad. This is running on my VPS server. And so I have about a 2-core server with 8 gigabytes of RAM. So the model is extremely high performing model. It's a very, very good model. And if we go ahead and actually check on the, we check on the execution here, we can see that this is the last one that we did. And it took about 23 seconds. So this is just the embedding and ranking feature itself, right? The LLM itself might have like a delay or latency, but this took 23 seconds, embedding 50 documents, all right? And then as you can see, if we go ahead and actually click on the final output, you can see that this is the final output here, all right? And so it's a really, really effective way to do that. And then of course, if we go ahead and we just want to test actually how long it takes for fewer results, right? So instead of returning the top 50, let's say that we want to return just 30, right? The top 30 results. This is on the front end. So what's going to happen is when we go to embed, it's only going to have 30 results to embed. All right, so we go there, and then what we do is we ask another question. And let's go here, and let's say, actually like this one. What are the benefits and advantages of purchasing a traditional home versus a prefab home or designing and building a 3D printed home given the US real estate market in 2025? So let's go ahead and check on that. And so let's see how long it takes to run and get back an answer. Usually if you have about 20 or 30, like I said, it takes about 10 to 12 seconds, okay? And so it's gone through and it's gotten the results, and it's giving us the benefits and the potential disadvantages of each option that we asked about, all right? And then finally, if we go ahead and see what the actual execution time is, we can see that it's about 12 seconds, right? So it's not bad, actually. And if you're using this on your VPS and, maybe you have an application that is like a research report or summary where, your chat responses, the response time isn't necessarily an important thing. This is definitely a great way to do that, right? So like I said, this was a great project. And, it really sort of tests the limits and tests exactly what N8N can do. And it really shows you the power of what N8N can do for you and helping you, create your applications, especially for your AI chatbots. So if you're interested in getting the files to this, I'm going to actually have a link so you can actually download and clone this exact project. And there also going to be a link if you want the whiteboards on all of the the N8N workflow whiteboards. We'll actually have that available as well in a separate link. So I hope you had fun. Try this yourself. See how you can use this in your own projects. And I'll see you in the next video.